Good day to all my students. Today we are here to continue on the chapter Carbon Compounds, where teacher will be doing part 11 and I will be concentrating on the subtopic called carboxylic acids. Now let's start. Carboxylic acids, students would have known roughly about carboxylic acid when we were studying or when I was explaining about alcohols, where alcohols can be oxidized using strong oxidizing agents which are potassium manganate 7 solution or potassium dichromate 6 solutions can be used on alcohols to produce carboxylic acid. And in this part 11, we will continue to discuss further and in depth of carboxylic acid. So let's start. Let's start with functional groups of carboxylic acid. So as you know, carboxylic acid has the functional group of COOH, and the name of this is called alkyl groups. And how are they written in structural formula is in this form, or we can even write like this. The presence of OH shows that carboxylic acid is derived from alcohol. So oxidation of alcohol homologous series will produce carboxylic acid where the functional group is COOH, and the functional groups are called alkyl group. Now let's start on the general formula. Each homologous series, as how I have discussed before, each homologous series will definitely follow one common general formula. So carboxylic acid has the general formula of CnH2n plus 1 COOH. Now this is what we call by the alkyl group that I introduced students beforehand. And CnH2n plus these are the functional groups. These are the covalent groups. Now let's go to how do you find the structural formula and the molecular, how to write and draw structural formula and write the molecular formula of the carboxylic acid group. Now let's go to, you will be surprised to find the first member of carboxylic acid starts from C0. Why C0? Because I don't want students to confuse that C0 means technically there is no carbon at all. Please remember there is one carbon which is already existing as in the functional group. So when you try to follow the general formula and using the concept carbon equals to 0, students will get HCOOH. Since there is at least one carbon existing, this is what we call by methanoic acid. Methanoic acid. Why methanoic acid? Because you have at least one carbon existing in the alkyl group. So that is the reason why, even though carbon starts with carbon 0, the first member of carboxylic acid starts with carbon 0, students must remember that there will be at least one carbon So the moment we see at least one carbon, that is where the name methanoic acid comes from. And how would you draw the structural formula of this methanoic acid? H C O OH. So this is how we draw. Now I will show examples of one or two carboxylic acid, and another important information that I want students to know is how we name the carboxylic acid. Now please look at the last prefix, which is prefix depends on the amount of carbon. Since we see at least one carbon, even though carbon here is 0, it is called methanoic acid because at least one carbon exists here. Second is, please look at the word OIC, methanoic acid. So methane is actually thanks to the amount of carbon existing in the molecule. OIC or methanoic acid is because of the carboxylic acid group, like alkene, double carbon bond. So alkene has E at behind. So every group of carboxylic, every member of carboxylic acid will have OIC acid as at the end of the name. Okay, so let's start with C1. C1 will be CH3 C. So while watching this video, students can work the general formula out with teacher. Okay, so COOH. Now please don't get confused. Even though it's a C1, you manage to see there are two carbons here. So that is the reason why this will be ethanoic acid. OIC. Ethane is because of two carbons existing in the molecular formula, and OIC thanks to the carboxylic acid. And how would you draw the structural formula of this? Okay, so this is how you draw the structural formula of ethanoic acid. So same follows. Okay, teacher not going to give you example of all, and for your syllabus you have to know up to butanoic acid. Okay, so it will be C2H5COOH, 2 plus 1 3. So this will be propanoic acid, and C3H7COOH. So don't be confused with the amount of carbon that you see only at the front of the molecular formula. You have to take into consideration, students have to take into consideration the another carbon which is at the functional group. So 3 plus 1 will be butanoic acid, and at least teacher will draw the structural formula of butanoic acid, which is 1, 2, 3. COOH. So when you draw, now if you are confused, if students are confused with how to name this molecular formula, you can try drawing the structural formula. So structural formula will give away the amount of carbon that you can see here. 1, 2, 3, 4. So obviously it will be says that it has 4 carbon in the molecule. So butanoic, OIC, every carboxylic acid must have OIC, butanoic acid. Butanoic thanks to the amount of carbon which is C4. But please don't be confused that the first member of carboxylic acid, methanoic acid, is said to have C0. C0 means only here the C0 is applicable only at the front part. Okay, teacher repeat, the C0 is applicable only to the front part. So the COOH does not change. So that is the reason why when students calculate as C0, when you put in N as 0, you will end up with only one hydrogen available, but with one C at least at the functional group. So that is the reason why it is said to be methanoic acid. So the first member of carboxylic acid C0, second member C1, third member C2 and fourth member C3. Okay, so this is where teacher would like to highlight. Why? Because this is where majority of the students you make mistakes when answering. Sometimes the questions will ask the second member of carboxylic acid. So students, you make mistake, second member straight away you will take this, but actually the second member of carboxylic acid is actually C1. So please remember that. Now let's go to preparation of carboxylic acid. This is very important. Now let's go to preparation. Now preparation, we have two ways. So you can prepare two ways carboxylic acid, which is initial product. Now see what I mean by initial product is in the industry, the initial product to prepare carboxylic acid, mainly ethanoic acid, will be crude oil, petroleum, natural gas and carbohydrates. Now why initial products are said to be petroleum, crude oil in the form of crude oil, natural gas and carbohydrates? Because all these three substances produce alcohol. So alcohol is the main raw material for production of carboxylic acid. But here in your syllabus, in Form 5, in this syllabus, we are going to concentrate on the preparation of one type of carboxylic acid, which is ethanoic acid. So ethanoic acid, how is it prepared in laboratory? Is through the oxidation of alcohol. Now please remember, if I want to prepare carboxylic acid, namely methanoic acid, please use methanol. If I want to prepare ethanoic acid, please use ethanol. So I hope students can understand that the connecting alcohol produces the connecting carboxylic acid. Meaning, if students use ethanol, you will be getting ethanoic acid as the product. When it is oxidized with two of the most strong oxidizing agents, which are potassium manganate 7, acidified potassium manganate 7 and acidified potassium dichromate 6 solutions. Now, if you want to write the structural formula, no, let me start with molecular formula. Molecular formula of the preparation of preparation of carboxylic acid, namely ethanol, in the laboratory. This is how we write. Okay, so allow me to explain how do we write the molecular formula for preparation of ethanol in laboratory. So here teacher will give you, students examples of ethanol. Okay, so ethanol goes through oxidation thanks to the presence of potassium manganate and potassium dichromate. Use either one, acidified potassium manganate and potassium dichromate. So please look here that the two atoms comes from the either potassium manganate 7 or potassium dichromate 6. Either one of them will supply oxygen atoms, not oxygen molecule. Oxygen atoms to produce ethanol will produce ethanoic acid, and water will be produced as the side product. So please remember, if students want to produce propanoic acid, students can use propanol with the help of two major oxidizing agents, potassium manganate 7 or potassium dichromate 6 acidified, added with a bit of acid to produce propanoic acid. So can you see the pattern? Ethanol produces ethanoic acid, propanol will produce propanoic acid. So in the laboratory, students can prepare ethanoic acid with the oxidation of ethanol, where the ethanol and potassium dichromate 6 or potassium manganate 7 is heated under reflux. Okay, heated under reflux, and when students produce ethanoic acid, it has a vinegar smell, colorless solution. And another important characteristics that I would like to highlight here is, please remember that it is an acid. When students learn about acid and base, when students were learning about acid and base, teacher would have give example on strong and weak acid. Strong acid, namely hydrochloric acid or sulfuric acid or nitric acid. But when it comes to weak acid, ethanoic acid is given as example. So this shows that carboxylic acids, the homologous series carboxylic acids are weak acids. Okay, so carboxylic acids are weak acids. So what happens is this gives the vinegar smell and changes blue litmus paper to red. Okay, even though carboxylic acids are weak acids, carboxylic acids still show the properties of acid, where the blue litmus paper will change into red. Now let's go to physical properties of carboxylic acid. So as we know, boiling point will increase. So boiling point of carboxylic acid for methanoic acid is roughly around 100 degrees Celsius and will increase as carbon. When amount of carbon atom increases, of course the boiling point will increase. Okay, so thanks to when the molecule becomes bigger and bigger and bigger, of course the boiling point will increase as the amount of carbon atom increases. Now let's go to solubility. So students can say that since carboxylic acid has two groups, carbon chain and functional group, the carboxyl group, only certain part of the carboxylic acid can dissolve or soluble in water. So that is the reason why we can say the first 3 or 4 members of carboxylic acid are soluble in water, but as the amount of carbon increases, the solubility decreases. Okay, solubility decreases as amount of carbon atoms increase. Why? Because when the amount of carbon atom increases, the covalent properties becomes more prominent, more significant, more stronger. So that is the reason why the maybe first 2 or 3 members of carboxylic acid might be soluble in water, but don't be surprised when you go further and further and further down the carboxylic acid, you will find that the solubility decreases. Now let's go to density. So we can say that density of carboxylic acid is less than water, so they are prone to float on the water. Why? Because the density is less than 1 gram per cm cubic meter. Okay, so per cm cube. Okay, so that's the reason why we can say that the density of carboxylic acid is lesser than water. So teacher will continue about the chemical properties of carboxylic acid in part 12 video. Till then, thank you for watching. See you all in the next video. Thank you.